those. I'll show those in a minute. Now, Jack, I think you asked this question last week. Yeah, put some batteries in those things. Jack,
Yes, sir.
you asked about parallel and serial circuits.
Yeah.
So if you have a serial circuit, a battery here, you found out last week that almost all the batteries were the same, right? Even the little ones to the big ones. The big ones are what? 1.5 volt, 1.5, okay, 0.5. So what you do is add these up. Now you've got 4.5 volt.
Yeah.
That's parallel. It's like a train going down track. And the same in your computer. When you talk about bytes in the computer and bits and so on, it's the same thing. So if you take them and take them like this, now we're what?
Series.
Parallel.
So the top is series.
This is serial.
Right.
Serial.
Okay.
Parallel.
Okay.
So the difference here is this doesn't add up to more volts. This will come out at 1.5 volts.
But you get more time
Finish it.
out of the parallel.
Right. It'll last longer because what? Anybody? What you're going to do is increase the amps. You're going to increase the current. Okay. We've gone over the easiest way to think about currents and electricity is using a water example. You have a tank. In the tank you put water. You have a faucet down here. You're going to turn on or off. That's your resistance. You open it up. Now you have flow. That's your pressure coming down. Okay? So you've got pressure here. I'm sorry. That's your current. So if you got a stream, for example, on our streets, when you drive and should be crossing it, if you've got a river this wide and a bridge this wide, and it's holding back the current, that's why it can take the bridge out of commission or take your car out and so on. That current is here, and then it's going to be narrowed down. Okay, and then it will open up again on the other side. Okay. So you have the flow, you have the pressure coming down, then you have the current, okay, which is your amps. Pressure is your volts. Okay. Your resistance is the faucet. You open it up full, not a whole lot of resistance. You start closing it down, you're adding resistance. When you cut down the current flowing down through the river, through a dam or whatever, that's your resistance. So the equivalent here on the water example would be if you have one tank and put another tank on top of it, but bringing water down. You brought up. Therefore, you have more time. It'll last longer. Right. Well, it'll last longer here over one battery, but you won't have more power to run it. And your power in, we didn't talk about power. Power is the equivalent of, take the resistance out. Power is measured in watts. So a lot of things that we do electronically with speakers and amplifiers for sound and so, we measure them in watts. This speaker system will handle 1,500 watts, for example. So that's the power. Okay? So that's the part of the equation here without the resistance. Power is current times volts. So that's the other equation. And if you need to know watts, then you'd have to calculate it that way. Okay? Don't get the batteries in. You've got what? You've got 4, you've got 2. Okay, try and measure and see if you get the voltage.
Somebody's gonna have to take me by the hand.
We need sleeves.
I gotta get you.
Yeah, but they're not script, are they?
They told me that one, these two, red and black.
I didn't bring it.
And again, remember, we talk in specific numbers, and this is hard for a lot of people to understand, especially the young ones I talk to. When we say that that's 5 volts, a 9-volt battery, that might be 9.8 volts. And as you're gonna use it up, you're gonna use up volts, so when it gets down to 5 volts, it probably is not gonna run anything anymore. So your meter's not always gonna be exactly what the thing is rated at. This is 1.5. Well, Jack, you remember last week? Remember? They weren't
Yeah,
rated at 1.5, it was 1.75 or 1.49. So again, your plus or minus range in anything in science is very important. Plus or minus 10% or plus or minus 5%. So when you buy something, your spec sheet, you have to look at it and see. Because it does come important depending on what you're working with. If you're working with motors, that battery may have more than what it says coming out of it. Go ahead.
When I turn this thing to B for voltage, correct?
Right.
Why is it beeping?
Well, sure. Oh, you put it in the wrong one. That's not the one to use. It's black. That's red. This is different. We're probably gonna get
you
that.
had all the
Okay.
black one.
No, but I think we just lay it here. Yeah, there's 6.4.
Thank you.
These are,
If you touch it, will that affect the reading?
Yeah, you have to touch it to get it.
No, but I mean touch it, I don't mean touch these two, I mean touch it with your finger while you're doing it.
that would take away my 6.
4 plus 2 is 6.
So that's the same.
But now, do I have it set on the right
This
thing?
is not
All right, you should have 3 volts coming out.
This is
No,
in
wait a minute.
series.
You don't have it set on the
See,
right.
that's the thing.
There.
Right, that's why it's gonna be more.
Don't you?
Put more in, just like theirs. You got yours read yet, Jack?
Sir?
Their 4 here is reading 6.39.
Yeah.
DC volts,
Put it on volt.
Yeah, you need.
20 range, it should come up 3.
Yeah.
That's
You,
what it
that's
should
just,
be.
just check right down on the batteries. and
Well, I
see.
wondered if we couldn't check from down there and make it a lot easier. Oh, you mean,
Here, get on the black side.
Well,
oh,
Oh, I got the black one. Take the red and put it on that. Oh, come on. Here we go. Yeah, 1.6 volt.
No, not yet, that's on the
okay.
list.
So the two of them
would
together.
make 3, okay.
Somewhere, something, then you can get hooked up with it.
Well,
we'll try it again. If not, I've got more of them.
Yeah.
Just put it in.
Now, wait a minute, you might, let's see.
With LED lighting and
Did he just give you those?
Now,
yes, at the beginning of the time.
Yeah.
let's try black here.
Once we're through there, we'll get to a different kind of battery.
Go ahead and try.
I
red.
can't see the red. Okay.
I have some alligator clamps if they're easier to use.
Yeah. I hate these prongs there, I can put clips on. something right.
We'll get a different one. That one might not work.
Yeah,
Well, we
sure.
sure.
That's what I use. Mine, I had one of those. And I checked my, you know, I like batteries.
Oh. Yeah,
It's
that's
good.
I don't know. 2 years.
That's a
It's
general.
not battery, it's Harbor Freight. No, good one.
I have a book, they sent me a
Yes, sir.
book.
These are straight.
And they sent me a book.
But I'm not a man tool.
Yeah, well, they sell more than just man tools.
Yeah, they do.
They,
Goes in.
I have.
Get on the rest.
Okay.
Yeah, I know, I had to take it out of my pocket. I got to ship.
Here we go.
None.
Oh, they don't allow me to carry a pocket knife on the shirt?
Well, I took it out because you have to go through metal
Ship both
detectors.
batteries.
They take it away from you if you're in an airport.
Yes.
They took one of my nice ones away.
There it is, 6. It's right here.
That's
Well,
what
this one's on a fingernail clipper thing. but it
Yeah.
don't-
Right.
I had one that was a USB knife. It was USB, and that knife,
162.
it's over like Chicago.
Sometimes
This is
they're
the
different.
plywood one, that long one, long enough.
Pizza. It's stuck in there. There's more plastic.
Yeah.
It's in a plastic envelope.
Yeah.
Once you get in there.
No, it's sealed in plastic.
Yeah.
Nothing.
Yeah.
Wires.
Nothing on the other one too.
Yeah,
Watch fingers.
Yeah.
that's right, because you're coming in on the
I don't have
negative.
any platelets.